for the first one? What'd you think? So for the first one here, from -3 to 7, so you're going from -3 -7 to 3, so right to there. So you're going for this area right here. What's the area right there? Yeah, that's just going to be, oh, wait a minute, are you sure it's 12? Look at this, it goes up to 2, and it goes from negative, so it's going to be, what's the base? 4, and what's the height? 2. So what's the area going to be? 8. You have to be real careful. This one's a little tricky because the scale is different on the y-axis. So now knowing that, what about b here? 0 to 3, that's going to be this area right here. What's the area of a triangle? What's that formula? Yeah, and what's the base of this one? 3, and what's the height? 2. So what's the area of this one going to be? 3. So based on what you just learned right. So what did you get for C? Someone give me C. Let's just give me C. Someone give me C. Sarah, what's C? -3. Sounds good. What about D? Who has D? 4.5. What about E? 11. F?
1.5.
So 1 point, not 1, 1.5. And what about the next one?
12.5.
12 point what? 5. Now, do you notice how you can add things, certain things together and get other ones? Oh, did I freeze it? I'm sorry. You can't see it, can you? So yeah. So for example, what do you have here? You have E and F. Add them together, and what do you get? Add them together, and you get 12.5. You can divide integrals and put them together that way as long as they're integrating the same function. So what that means is, look, if you're going from -7 to 0, and then you're going from 0 to 6, that's the same thing as -7 all the way to 6. What you'll see is that the integral from a to b of f of x dx plus the integral from b to c of f of x dx, what is that going to be equal to? What can you combine that to make it? The integral from what to what? From a to c of f of x dx. And it's important to know you can go both directions. You can go in both directions. The other thing I want to emphasize right here is integral, area under the curve. We say that, but it can be negative, right? We're not really doing area because area is strictly a positive quantity. We say it because it's easy, but you have to remember it's net change is the more accurate way to say it. The net change is positive or negative. You will estimate with Riemann sums when you have curves. But what's nice about this? What did we state at the beginning? These are all what? They're all lines. So can we actually calculate them exactly? The basic moral of the story here is don't forget your basic algebra and basic geometry. So for example, sometimes in BC calculus, we'll have like semicircles will pop up, and the kids will try to write integrals for them, which you can do sometimes, but sometimes kids do this huge long amount of work just to find the area of a circle. And they're like, oh wait, I know what the area of pi are. You can use basic geometry functions. So just as an add the total area issue. Well, 0 to what? 0 to 3, because this comes out to be negative when you do it, right? So let's say you wanted to just make it all positive. What can you do to a function to make it all positive? Yeah, so if you did this, the integral of from what, 0 to, what does it go to? Not 0, it goes from -7 to what?
6.
It's -7 to 6. And what's the only thing you put in there? Absolute value of f of x dx. If you put in the absolute value sign, what does that give you? All the positive. It changes anything negative to positive. That would give you the total area between the function and the x-axis, regardless if it's below or above the x-axis. Regardless if it's above or below. On your calculator, do you know how you can put in absolute value? No. Some of you have math type and you can put in bars, but what you're looking for if you don't have that is ABS. ABS and then anything inside it will be the absolute value of that thing. The absolute value of that thing. So this is what I'd like you to do right now. Use your calculator and just do A. Sketch on OneNote right here. Okay, so when I hit graph, from -4 to 4, I hit graph on this thing. Boom. Look what happened. Oh, it's so pretty. It is exactly what I have there. It is exactly what I have there. I can go back. One sec.
Mine says there's a domain error. I think
the button is window. Oh, change plot. You might be trying to plot some points from a data set. Y equals right there. That's what it should look like, everybody. It looks like from 1 to maybe 1 to 3 is big here. That looks about the same, but this part right here, everybody, look how far down it goes. It goes down to -15. So this thing is really narrow, but it's really long. It's really tall, I mean. So it comes out to be negative, which kind of makes sense. Now for the total area, what's the only thing you need to change? What's the only thing you need to change in the integral expression if you want the total area between the function? You add in the absolute value, so it's going to be the integral from 0 to 5 of the absolute value of f of x dx. Now, if you were going to do that on your calculator, we plug that into the calculator. What you can do instead, what you can do up here is second insert, and then what is it? I think it's math, number, yeah, absolute value. See that? Oh, see how on mine it gives the 2 bars right there? What do I need? I need to now type it all out again. So it's going to be x to the third minus 9x squared. Oh, x to the third minus 9x squared.